So when we left off in lesson 2, we had just run this particular model for the Poisson distribution. And so you'll see here the only two remaining ones that are significant are fire control and search and rescue. Hazard is weaker, 0.167. Fire rescue hazard is not very strong, 0.21. And again, if we're going to reject the null, we need to be less than 0.05 here, right? Or we can make some minor inferences if it's less than 10 because that's a single tail test. But generally speaking, we're looking for less than 0.05. So here, by going to the new dependent variable and a Poisson model, we see that the too significant. We lose one of our fire rescue hazard, and actually hazard picks up a little bit. It's a little bit stronger in this sequence. Okay. So let's go to the next one, and the next one is the negative binomial. Remember that the Poisson has a functional form that has to go out and then before it goes up and then down, right? And so the nice thing about the negative binomial is it has an additional term in it that allows it to start very high at the zero event and go all the way down. So it's a nice linear or curvilinear functional form from a very high level at 0 all the way to the asymptote on the x-axis. So in this case, because we have a lot of zero injury observations, we should be pretty sure that that the negative binomial will be a better model. So let's take a quick look at it. We could go up here, we could do count outcomes and do the negative binomial regression. But I'll show you just the alternative way. One nice thing about Stata is it does kind of just work with some simple commands. And so we can click in that command structure, we can arrow up, and just keep arrowing up until you get to what was in Poisson. And here we had negative firefighter injury in our different dependent variable on the other ones. The command for negative binomial is nbreg, right? nbreg. So we're going to just put that one in there, and then we're going to see what we come up with by using the different functional form. So it went through, it's going to first estimate a Poisson model, then it's going to estimate the constant only model, and then it's going to fit the full model. You kind of have to click enter as you go through here to the end. And so what we get here is at the end, we do the likelihood ratio test of alpha equals 0, and essentially alpha is the adjustment that takes place between the negative binomial and the Poisson. And so what we find there is that doing that likelihood ratio test, it's very high, 235, and so we definitely needed to do a negative binomial. Let's do the fit stat really quick. And so the AIC here at the end is 851,390. Let's go up here. And so the AIC at the end of the Poisson model was 1,084. So that's a huge difference, right? And so essentially we have improved our model by putting in these functional weights that allow us to take out a lot of that zero, that overburdening at the zero injury category. Let's look up in the results. So now after we controlled for a little bit better functional form, fire control still significant, very significant now. Search and rescue is big and still significant. But notice hazard has come really close. Now it's about 0.07, 0.08. We could say that that is significant with a one-tail test. And fire rescue hazard is still a little shy there. But generally, everything, notice how everything improved on this model specification. Now, the one thing that we have to be concerned with is we know that we improved our model by going to a negative binomial, but the last thing that we know is we have a lot of over dispersion, under dispersion in that no injury category, right? And so in those cases of over dispersion or under dispersion in the model, right? What we want to do is we always want to try to fit a zero inflated negative binomial to see if we can get an improvement there. So what I'm going to do is I'm going to run the zero inflated model right now. Okay, so let's look at the fit versus the zero inflated negative binomial and see if we need to control for that to improve our model specification. The first thing that we'll do there, we can again click into the command window. You can just function arrow up and go to this nbreg command. Here we just do ZINB, but we have to do something a little bit different because what zero inflated requires, it requires that you specify an inflation. God, if I could only type NB respond. Alright, and then what we need to do, I can't remember if we need to do anything else. Let me pause real quick and I'll make sure that I did everything correctly. Oh, and I did forget something. We need to put in this term here, V-U-O-N-G, Vuong. And Vuong includes a test that tells us if the zero inflated is an improvement over the negative binomial. So we'll see. We'll run this thing, and it'll at the very end it'll have a test statistic to tell us whether we need the zero inflated or not. Okay, so we're going to click return here. And this one takes a while to run. It really does. It's a pretty complicated model. And you get some not concave, so it's a pretty complex likelihood function. When you have these kind of not concaves popping up, that's telling you that you've got some complex functional forms going on, or likelihood functions. Here, we're going to get down to the bottom here. Alright, good. And I'm going to run fitstat really quick. And then that takes a while too. And then we'll talk about what we just did. Okay. That'll run a little bit there. Okay, so notice that when this output comes, we have these parameters here still, and we have coefficient and standard errors and probability of zero, the probability levels, right, and the z-scores. Notice we have two different estimates going on. We use this inflation. What that does is it's essentially a logit model that predicts whether we're going to have zero firefighter injuries or more than one firefighter injuries. Essentially, it does a dichotomous estimate of whether the outcome is going to be a zero or not. And then what it does is we run the actual negative binomial on those dichotomous variables up there. After we do that, right, so after we control for all this, we go back to search and rescue, and fire control are both high, and hazard declines a little bit. So after we control for the overinflation in the number of zero injury observations, right, we actually lose that hazard and fire rescue hazard value. And so that's not bad. It's just telling us that it's a weaker relationship for those two. But we're very sure that search and rescue and fire control are significantly more likely to have an event. Okay. Now, if we go down here and we look at the fitstat, this is down to the AIC value is 824. The likelihood value is, let's look at negative 402. So let's go back up and let's page up and look at what that is. So negative 402 for the likelihood function and 824 for the AIC. Let's compare that above. If we go up and we look at this one 824 versus that AIC, negative 416 versus, what was it, 402. So yeah, we had a nice improvement there, 402, 824. Let's go up and look at that versus the first one, the Poisson distribution. That's 534 for that one. So the Poisson functional form doesn't fit this data at all. And the AIC is really poor versus that 824 number. So essentially what we do is we learn that we did need to do the zero inflated value in order to assess this data. The other way that we know that is this Vuong test, right? So if we go up in this issue, what they do is they fit a couple of models here, right? So they first fit the constant model, and then they fit the full model, and it goes through. And so if we go down here, what it'll do is it does the Vuong test of the negative binomial versus the standard negative binomial, and it does a z-score. That z-score ended up about 2.7, which is significant at 0.003. So we're very less than 0.01. We're sure that we should have used the zero inflated. So that tells us essentially what we need to know. And this is the best model specification of the three. It's preferred on AIC, on negative likelihood, log likelihood, etc. So that's pretty much where we're at. What we need to do now is we need to go through and do a few, do some post-estimation commands. Actually, I want to do a couple things to kind of test the robustness of our results.